The paired samples t-test is used when a study needs to determine whether the same participants changed across two related measurements. It is chosen when the research problem and literature gap point to uncertainty about change within people rather than differences between separate groups. This test is fundamentally different from the independent samples t-test. Instead of comparing two groups of different people, the paired samples t-test compares two scores that come from the same people or from intentionally matched pairs. The central question is not whether one group is different from another, but whether individuals changed across two related conditions. Conceptually, the paired samples t-test is designed to compare two related means. The outcome is numeric, and each participant contributes two scores that belong together. Most often, these scores come from a before and after situation, such as a pretest and posttest. However, pairing does not require time. The same participants might complete two different tasks, rate two related conditions, or be measured under two linked situations. What makes the data paired is not time, but the fact that each pair of scores comes from the same person. This is also one of the most common ways an intervention is studied when the design does not include two separate groups. In an intervention study using a paired structure, the same participants are measured before the intervention, and then measured again after the intervention on the same numeric outcome. The analysis focuses on whether the average change from pre to post is statistically meaningful. This approach is often used when it is not feasible or appropriate to create a separate comparison group, such as when a program is being piloted with one cohort, when a service is offered to everyone, or when withholding the intervention would be unethical or impractical. It is important to understand that this design can show whether change occurred after an intervention, but by itself it does not prove that the intervention caused the change. Without a comparison group or stronger controls, other factors such as time, experience, or external events may also contribute to the observed change. Because of this structure, language matters. For a paired samples t-test, the research question must include the phrase statistically significant difference, and it must clearly signal that the comparison is within participants. Phrasing such as before and after, pre and post, time 1 and time 2, or across two related conditions makes the paired structure visible. The wording tells the reader that the analysis is focused on change within the same individuals rather than differences between groups. The paired samples t-test requires one numeric outcome variable measured twice. Each participant produces two related scores, and the analysis focuses on the difference between those two scores for each person. Rather than comparing group averages, the test examines whether the average of these individual difference scores is statistically meaningful. In simple terms, the test asks whether the typical amount of change across participants is unlikely to be due to chance. A core concept for this test is dependence. Dependence means the two scores are linked because they come from the same person. This dependence is not a problem. It is the reason the paired samples t-test exists. A quick way to decide whether data are paired is to ask whether the same person appears in both sets of scores. If yes, the data are paired and this test is appropriate. If no, and the scores come from different people, an independent samples t-test is required instead. It is also important to understand what change means in this context. Change does not automatically mean improvement. A paired samples t-test can detect increases, decreases, or no meaningful change at all. The test does not assume the outcome will improve. It simply evaluates whether the average difference between the two measurements is large enough that it is unlikely to have occurred by chance. This test relies on several assumptions that support trustworthy interpretation. The difference scores, meaning the changes from the first measurement to the second, should be approximately normally distributed. The pairing must be correct, so that each person's first score is matched with their own second score. The outcome must be numeric and measured consistently across both measurements. Measured consistently means that the same instrument is used, the same scoring rules apply, and the conditions of measurement are kept as similar as possible at both time points. This helps ensure that any observed difference reflects real change, rather than a change in how the measurement was conducted. When assumptions are violated, the study is not automatically invalid, but interpretation becomes more cautious. Extreme outliers in change scores can distort conclusions about average change. Inconsistent measurement across the two conditions can weaken confidence in the comparison. Incorrect pairing undermines the logic of the test entirely. In these cases, transparency and careful interpretation are more important than forcing a conclusion. Results from a paired samples t-test are interpreted on 3 levels. Statistical significance indicates whether the average change across participants is unlikely to be due to chance alone. Statistical significance does not indicate how large or meaningful that change is. Effect size addresses that question by describing how substantial the change is in practical terms. Power explains why some real changes are not detected, especially when sample sizes are small, or when changes vary widely across participants. A non-significant result may reflect limited power, rather than the absence of change. One study might ask whether there is a statistically significant difference in mean writing scores before and after a tutoring intervention for the same students. Another might ask whether there is a statistically significant difference in mean anxiety scores before and after a support program for the same participants. A third example might examine whether the same employees report different levels of focus when completing 2 different task types. In each case, the same individuals contribute both scores, which makes the paired samples t-test the correct analytic choice. The paired samples t-test is not appropriate when comparing 2 separate groups of people. It is not appropriate when there are more than 2 repeated measurements, which would require a repeated measures ANOVA or another approach. It is not appropriate when the outcome is categorical rather than numeric, or when the goal is relationship or prediction. When the paired samples t-test is chosen correctly, that choice should be visible throughout the study. The research problem should point to uncertainty about change within participants. The literature gap should justify examining whether change occurred. The purpose statement should signal a within-participant comparison across 2 related measurements. The research question must include statistically significant difference and clearly indicate the paired structure. When these elements align, the paired samples t-test becomes a clear and defensible analytic decision rather than a guess.